How does NASA study vestibular adaptation in astronauts? In recent news, NASA is making headlines as it investigates how astronauts adjust to the unique challenges of space travel. The question many are asking is, how does NASA study vestibular adaptation in astronauts? This topic is particularly relevant as space missions become more frequent and ambitious. Understanding how astronauts maintain balance and orientation in microgravity is essential for future explorations. NASA's research focuses on the vestibular system, which is located in the inner ear and plays a key role in balance and spatial awareness. In a microgravity environment, the lack of gravitational cues can lead to disorientation and motion sickness. To tackle this issue, NASA employs several scientific methods. Before astronauts even leave Earth, they undergo pre-flight training and testing. This includes assessments to measure their vestibular function and balance. For example, astronauts participate in rotary chair experiments where they experience controlled rotations. These tests help establish baseline data for future comparisons. Next, NASA conducts parabolic flights, which create short periods of weightlessness. These flights allow researchers to observe how the vestibular system reacts to sudden changes in gravity. Additionally, astronauts train in neutral buoyancy labs, where they practice movements in a simulated microgravity environment. During actual space missions, astronauts perform various tasks while their eye movements, posture, and coordination are monitored. Researchers use eye-tracking goggles and motion sensors to collect data on how the vestibular system functions in microgravity. This real-time monitoring helps identify how quickly astronauts adapt. Once astronauts return to Earth, they undergo post-flight evaluations similar to their pre-flight tests. This allows researchers to measure how well their vestibular systems readjust to Earth's gravity. By comparing these results, NASA gains insights into the recovery process and any lasting effects. NASA also utilizes virtual reality and simulation technology. These environments help train astronauts to cope with vestibular challenges by simulating disorienting conditions. This training is crucial for preparing astronauts for the realities of space. Moreover, NASA supports animal studies to investigate vestibular function at a cellular level. Computational models are also used to predict how vestibular signals change in microgravity. This research assists in designing effective countermeasures. Through these various methods, NASA is gaining a better understanding of how the human body adapts to spaceflight. This knowledge is vital for ensuring astronaut safety and performance on long-duration missions. As space exploration continues to evolve, studying vestibular adaptation remains a key focus for NASA.